I'm quite active on Twitter, so if you want to chat with me, then Dan Limerick on Twitter is a good way to contact me. And at the moment, I'm writing a series of blog posts about TDD and legacy code, and you can find those on danlimerick.wordpress.com. Okay, so how to define legacy code? What is it I'm going to talk about? Before I define it, though, I'm going to go through how the process of legacy code is created. So, I mean, even the worst legacy systems usually start pretty well. So, say year zero, you have a company decides to build a new system. Developers are really happy as they'll be working on a new shiny project. It'll be the latest technologies. I mean, this is like developer paradise. It's what everyone wants to do if you're a developer. And if the team is any good, if they're like competent people working on the team, then this phase is really fun. I mean, the code is elegant. Features fly out the door. The customer's really happy. Everything gets done really quickly. And then maybe after a while, year one, things start getting a bit fatter. Classes are getting bigger, more methods, more lines per method. This is usually when the first bugs start cropping up, because they're not just adding new code anymore. You're sort of changing code, and it's sort of when you have to sort of introduce a bug tracking system and maybe a bit of change management. And but things are still going pretty well. The customer's pretty happy. Things still getting done, and I mean, a lot of systems can stay around this, year one, that phase for quite a long time, especially if you have a good team and a bit of discipline. But say year two, or it might not be just year two, it could be a couple of years later. Say a bump in the road comes along. So maybe your 2 or 3 top developers decide to switch jobs. It's pretty common in our industry, and usually goes in waves as well. One quits, and then the other 2 follow with him. And a new team comes in, and they don't really see this shiny new system anymore. This is already a bit clumpy for them. It is class sizes are a bit too big. It's like, I don't really understand what the original developers thought, and so maybe don't really follow their ideas and the same structure. Maybe they've got another project on the side which is newer and shinier, and that's the one they really want to work with. So it's just get things done. I'll just put my code here in this corner here. It doesn't really matter if it's making the code base a bit worse. And then sort of after this, this just accelerates. Year 3, it becomes like the code base where you just do the quick fixes. You just want to get in and get out fast as you can. I think everyone has seen those systems. The ones that you get a week and say you have to fix this feature. Okay, not that system. And this continues for a while until say year 4. Your customer comes back and says, we're loving this product. We're saving loads of money using this system, and now we want to build it out. You want to do a 6 months, 12-month project where we add in a huge new feature. And this is where it all just goes horribly, horribly wrong. You're building basically on a foundation of sand. There's nobody maybe that really understands the system properly, and the ground structure is not sound. And this is when we say that the bug fix death march begins. I don't know if any of you have ever been on one of these death marches. It's just like the worst thing that can ever happen as a developer, because you're trying to implement a feature, and just never ever going to get to 100% done. You might get to 90% done. So you put out the test, customer tests it, comes back and says, there's like these 3 bugs. So then you go, okay, try and fix those bugs, but you don't really understand the whole system. So then there's a ripple effect. So you introduce new bugs, which they find, and they come back, and now they're getting a bit angry. A bit more pressure, deadline is approaching. And then finally you fly past that deadline. You'd be like 3 months past it, way over budget. The customer's screaming, I want my system now. Panic, people are working overtime, and the code quality just plummets. It's just people do whatever they can just to fix the bugs and get the system out the door. So 5th phase, what are we going to do now? What happens now? Are we going to throw away the code, rewrite it? Really common. Maybe buy in a standard system, or you could sort of limp along for years and years. just fixing all the bugs. It's not that fun. Uh, or and any new features take ages and ages because it's impossible to time estimate. Like, how long is this going to take? No idea. I say a day, but it might take 3 weeks. So I think at this stage we can agree that we have created a monster. And this is the stage where lots of companies actually throw out their systems and buy new ones or start the rewrite. There's lots of names for what we've created now at this stage. I mean, spaghetti code jungle, or a big ball of mud is one that's actually very well defined, and that's a system that has basically no structure. It's just totally random where all the classes are and where the logic is. And the problem with this is that we have introduced accidental complexity. Say every domain is more or less complex, so maybe some financial domains or in banking something would be very, very complex, but that's we've introduced extra complexity, which is totally unnecessary. By not having any organization in our code, we've introduced complexity which is totally unnecessary and just makes everything really, really hard. So I think I have a tougher definition of legacy code. I think we can agree that the previous system is legacy code. Everyone knows it when they see it. But I would go even further and say that and follow Michael Feather's definition that code without tests is bad code. I would say that actually in our previous example that already in year 0 that our system started showing signs of bad design. It starts getting hard and hard to maintain. It's a downhill slope. And I would say that it's both possible to sabotage a code base after only a few months. I mean, I think people have probably seen projects where you start off with a prototype, and you don't throw away the prototype. You keep on building on it, and that's just like you're well on your way to a really horrible system. But I mean, so the other companies, I mean, disciplined programmers, they care about the system, care about the customer, they know the domain well. Then you can keep it around year 1 through a lot of hard work. But if they ever leave, then your system risks sinking back down into the mud. So you're really dependent on your 2 or 3 sort of lead developer who's been working with the system for years and know it really well. Okay, in 2004, Michael Feathers, who's an expert in this, working with legacy code, wrote a blog post saying basically, I don't care how good you think your design is. If he can't walk in, start writing a new feature, write a test for it, then you're not as good as you think you are. Because if he has to spend 6 months learning the system before he can write a new feature, then that costs money. 2012, K. Scott Allen, who's a presenter on the Herding Code podcast, paraphrased him and said, in today's world with Amazon and Facebook and GitHub and releasing every day continuous deployment, so if I can't walk in and commit to production day 1, then you're not as good as you think you are. So I'd say the bar is much higher now, and it's high time to get started and fix up your legacy code. There are a lot of different angles to this with legacy code. We could talk about lots of different aspects to do with legacy code. I mean, first off, it's a huge waste of money for the business. So I think after 4 or 5 years, they think they've built a system that is saving them money, and that they're going to build their business on. And instead, you come back and tell them, no, we can't build any new features. This is horrible legacy code. You have to do a rewrite. You could talk about that for an hour. I mean, it's a horrible experience for the end user. I think quite often it's like an enterprise system that you're maybe building for colleagues, people you work with, and they're sitting there 8 hours a day using this system, and they're usually buggy, horrible to work with. It just feels totally unprofessional. To know that you're delivering a bad system to them every day, people that sit beside you in the office. You could also talk about the flawed process. I mean, why does this happen? How does it get there? I mean, I think I've heard lots of stories about first you build a system, it becomes legacy code, gets thrown away, they do a rewrite, that fails as well. You buy a standard system, that doesn't work either, and just keeps on and on and on. But I am going to focus on the developer. Um, because I don't know if you've ever seen one of these projects or been involved in one of these, but it's really hard to keep up your motivation coming in on Monday morning and just knowing like, oh, I'm going to be not going to get this feature done. It's going to be 90% done. It's going to be bugs. That the customer won't be happy. It just doesn't feel good. And if this keeps up for a while, then people get depressed, and if you go into the death march phase, then people get burnt out. It just you can't handle it. And then I think I personally know lots of people that have quit their jobs just to avoid working with legacy code. Say no, life's too short. I want to work with greenfield projects. So it's just not fun, and it doesn't have to be like that. Just quickly talk about some of my own personal experiences. So, my first job was starting off with VB6, and then we ported that to C# and BizTalk, and that was actually really interesting. So it wasn't a death march. Seen lots of long, complicated store procedures. I think the actual worst system I've ever seen was a ASP.NET web forms, and it had 7 levels of inheritance for a web page, and it was like divide the web page up into lots of different parts, and all the HTML was written inline with response.write. So I think I did I only just touched on this system. Luckily enough, I wasn't really involved in it, but I was going to add a button onto a website. I said, oh yeah, that'll take me 4 hours tops. So 8 days later, I was going to, am I going to actually sort of remove all these 7 levels of inheritance and do a normal ASPX page? But that would take like 3 months. Or am I just going to go along with this response.write? It just felt really bad. And that system died. It actually was unmaintainable. It got replaced by another system. And more recently than extreme message chaining, which is, I think, pretty common. You might have something in your system like order service dot get orders by customer dot customer dot address dot postal code, something like that. And if any part of that chain is null, then you get a null reference exception. And that's really great, say, under like customer demos, your sprint demo on a Friday. And you go, oh, it's going to show this new feature, and they click somewhere, and boom, yellow screen of death. It's just really embarrassing, and especially when it happens like 10 times in one demo. The other thing, I think I've seen loads of homemade object relational mappers. So, mapping database code to objects. Some of them are pretty good, and some of them are really horrible. Okay, so what are your options? I would say that if you're not doing TDD or unit tests, then you're doing the first one, edit and pray. And that's what I did as well the first 4 or 5 years of my career. And you can get really good at it. I think I worked my first job working with a logistics system, really complicated. I think it took about 2 years for me to sort of learn the ins and out and have a fairly good idea of what would happen if I changed something. So I think after 2 years I was allowed to go into the big sort of invoicing store procedures and make changes in them. So the first year or 2 years I wasn't allowed to. It's like, no, it's just way too expensive if you make a mistake there. So consultants, they weren't allowed to anywhere near that code. They were like, oh, you're over in this sort of less important bit here. It went really well. I was really careful, loads of discipline. Double-checked, triple-checked everything. And then you sort of crossed your fingers, held my thumbs, deployed, checked the log, sweated a bit. And most of the time it went pretty well. But it's hugely inefficient. Just that it takes 2 years before anyone can make significant changes in the system. And bugs still sneak through sometimes. When you're doing your deployment, 8 o'clock in the evening, it's really easy to miss something, not copy over some DLL or something like that, and boom, this logistics system, the consequences were huge. If our customer didn't get their deliverance the day afterwards, that could cost like a couple of million euro every day. But there is the other option, if you're working with legacy code, is cover and modify. and that goes out. You choose out the bit of the code that you want to change, and you cover that with code. So you say, oh, if I pass in these 3 inputs, then I should get out this. And these can be at quite a, say for an invoicing module. So you say if I pass in these parameters in, that I should get an Excel page that looks like this out. And this sort of provides a safety net that sort of isolates that clump of code from the rest of the system. So you don't want any changes rippling through the system. So you want to know that I don't really know what this code does, but if the outputs change, then I've messed something up. And these tests, they also act like as a sort of a canary in a coal mine, then, as you say, that miners used to have these canaries with them, so if there was any gas, then the canary would die first, and they could escape to safety. It's be the same thing here, that you see, oh, tests are failing, I don't know why, but now it's time to revert my changes. And then once you have those tests in place, you can break that code up and write real unit tests, so you test like small units. And then eventually you can remove these covering tests because you don't need them anymore. You've tested on a much more fine-grained level. And this allows you to refactor and change the code and basically take those first steps to improving your system. Okay, I think I have to come in with a disclaimer here, though. This is not a silver bullet or a golden hammer or anything like that. It's really hard. I'd say if you're a beginner, it's really tough, and even for someone who has lots of experience as a programmer and knows the system and knows the domain, I mean, it's tough. It is harder than working with a new project. You have a lot of small decisions to make all the time. If I'm going to refactor this, how much should I do? I work as a consultant, so we get we cost 1,000 kroner per hour. So I can't just say, oh, I'm going to refactor the whole system. It's going to be shiny and clean. There's no new functionality. I'm just going to refactor everything. You can't. You have to stop. You have to say, where do I stop? How much do I do now? It's just way more decisions to be made all the time than with new code. So it does require a bit of skill. It's hard to get started, and experience. This is where it really pays. Where it's not like new technologies where it's hard to keep up. This is where actually the more experience you have, then the easier it gets to make these decisions. Experience really helps with that, and requires a bit of common sense. You have to know when to stop, how far to go. Maybe some bits of code should be rewritten and not refactored. It's just common sense. Take small steps. Be practical. Think your customer. Is this providing value for them? But in the end, I'd say it is all about attitude. Don't get depressed. See it as a challenge. It's a chance to learn some new skills and to be a much better programmer. I think if anyone has seen enough legacy systems, then you've seen these failed attempts. The ones where it's one test project, and there are 3 tests, and every test is about 50 to 100 lines of just incomprehensible. You can't understand what it's doing, and the tests are called like test 1, 2, and 3. None of them work, and they haven't been updated for the last year. And this is like typical for someone who says, "Oh, I'm going to introduce TDD into legacy code." It's just really hard to get this code under test because there's so many bits connected to it. Just to set it up, it takes lots of code and maybe even a database that you've set up in the background. And it's just too hard. I just gave up and said, no, we go back to the old way. As I say, there are a couple of success factors before you start, fixing up your legacy code. The whole team has to sort of be behind this. It's really hard to do this on your own. If you're like one of, say, 6 people, and you're the only one writing unit tests and refactoring the code, and then your teammates come in and just write, loads of other code and wreck your tests, you're going to lose your motivation really quickly. And plus the difference, a team that's behind this initiative is, you can get so much more done than just one person. Another factor is the business has to want to keep the system. It has to be a system that earns money for them. It has to be a valuable system because it's going to cost a fair amount of money to fix it. the team has to have time to improve the code. You can't do this in 3 weeks. This is going to take a long time. If it's a big system, it's going to take years. I'd say that it takes at least 3 months to start seeing significant improvements. And if you're only going to be working for 3 weeks on a system, it's not even really worth starting. You just won't get anywhere. And the last one, and which I'm going to try and help a little bit with, is team members need to know how. How do we get started? There's a couple of high-level strategies, and the most important one is it's the whole agile thing, TD thing, baby steps, small steps. You don't go in and say, now we're going to go right to the core of the system, we're going to rip it out, redo it, the first thing we do. It's just never going to work. You take really, really small steps, especially if you don't know the system. Then you start at the edges. So I'm doing a little function here, and I start refactoring those. And then after a while, you get to know the system better, and you can maybe go into sort of more towards the core of the system. But you find as well that when you write a test to fix a bug, that these could tend to come in clusters. So they're together all the time. So lots of bugs around the same part. You refactor that, and it gradually gets better. And the important parts of the system are the parts that change often. And you'll be in there writing tests, and it actually goes pretty quickly, even though you're taking baby steps. Actually, cover the important parts of the system. I would really recommend pair programming, especially if you're working with legacy code. Then a large part of it is actually just reading code, understanding what does this do, or how is this connected to everything. If you're two people doing that separately, then it's sort of a bit of a waste when you can do it together. It also helps all these sort of small decisions that you don't get paralyzed and think, oh, what am I going to do? This is impossible. I don't know how to go forward. Then having a person beside you really helps. After a while, so you've taken a couple of baby steps, you're starting to feel like now the system's getting a bit better at the edges. Then it's nice to have a vision. Like what's our perfect system? If we could redo everything, had unlimited time and money, what would it look like? I mean, what sort of structure are we looking for? And that should the whole team should share that. Then this has come up more recently: brutal refactoring or careful refactoring. So I've been talking about careful refactoring. You take it very easy, small baby steps. But I mean, if this is the system you've been working with for 10 years, and for example, some parts this bit just isn't really important. It's like, yeah, we can refactor, or we could throw it away. It doesn't really matter. We'll just do some brutal refactoring. We can go in and make big changes. But I would be very careful with that. And you don't want to be doing brutal refactoring on your sort of invoice logic. And the last tip then is facades. And that is that you basically give up on a part of the system for a while. So you say, we're refactoring this bit, but we'll sort of fence off one part of the system, and we'll say that's like a lost cause for the moment. We'll have some sort of facade, an interface between that part of the system and the rest of the system, so it doesn't contaminate anything. It can make it easier just to makes the whole thing a bit more approachable. Low-level strategies. Okay, these are two classic books which I would recommend to any programmer to read, even if you're not working with legacy code. The one on the right is Refactoring, written in 1999. And even if you've never read it, I'm sure you recognize lots of the patterns in this book. They're there in Visual Studio and ReSharper. Things like extract interface, rename variables, introduce parameters. All these ReSharper refactorings and in Visual Studio as well. They come from this book. Martin Fowler was the person that defined them. And they're actually made for this. So you want to make small, careful steps and not introduce any bugs. And then hand in hand with that is working effectively with legacy code, and it builds on Martin Fowler's book. It's written in 2004, but so adapts a lot of the patterns to how do you actually make code testable? How can I introduce refactoring without introducing bugs if I'm working with legacy code? And I'm going to show a few of the techniques from Michael Feather's book. But first thing today, stop writing legacy code. If you're going to do a new feature, doesn't depend too much on the rest of the system, then do it with TDD. then when you actually call the new method or your new class is called sprout method. And that maybe the call you can't actually test that where you're calling it in the old legacy code, but the rest of the code you can test that with TDD. You can write your first unit tests, get your testing framework up and running. This is like a really great way just to get started with it. Just to feel that I'm not actually making the system worse. I know that what my new code, what it does. Another technique is wrap method, which is pretty simple as well. So I have a before and after here. So if I have code like sending an invoice, does loads of complicated stuff. Gets an invoice from a database and sort of integrates with web services and SAP and all sorts of things. And I want to log this. But I don't really want to go in and change send invoice and add more code. It's already really long. It's already like 500 lines long. I don't want to add in more code there. What you can do is wrap it. And there's a couple of variations of this, but this is the easiest one. So I basically using ReSharper or Visual Studio, extract the code that's in send invoice into a private method. And here I call it send invoice to customer. And then I've created my new method, which is called log invoice sent, which I've created with TDD with tests. And then I put it before or afterwards. And then all the old code still calls send invoice, but now it's logged, without me having made the original send invoice method worse. There's two disadvantages to this. The first is that it's really hard to come up with good names. You can see here send invoice to customer is totally unnatural. And the other is that log invoice sent, it has to either become before or afterwards. So it has to be temporal code, it's called. It can't be something that actually needs to interact with code in the original method. Then wrap doesn't work. Okay, so now we're going to go in. If you actually, wrap and sprout, so a new code. But if I actually have to go in and change existing code, then you won't get too far with those. And now we encounter the paradox of changing code to test it. The problem is that I want to introduce tests so that I can make changes without introducing bugs. But to introduce those tests, I have to change the code. So, how can I do that? So the solution is careful refactoring. You take small, tiny baby steps. You do use refactorings from Martin Fowler and from ReSharper that you can be guaranteed that I can extract a method without breaking the logic. Or you can rename variables and nothing will get broken if you're in .NET and C# anyway. A bit harder in JavaScript. So start with a typical hard to test class. And this is Michael Fowler, not Michael Fowler, Michael Feathers. Gives them different names, like their detective cases, the case of the hidden dependency. So the problem with this is, if I want to test, this is an MVC class, or my order controller, and it depends on the order service class. So say I'm going to do something that sends an email and say something to a database. If I go new order controller dot send invoice, then I'm actually going to send an email and save into a database. I don't want to be doing that, sending test emails to people around me, my customers. I just want to actually test the controller part. The problem is that I can't get at order service. It's in the constructor. It's not. It's a private read-only variable. I can't get it from outside. So there's two concepts you need to understand to get past this. The first one is a dependency injection. There's three different ways, or three different sorts of dependency injection if you want to get at this order service class. And the most common one is constructor injection. So I extract an interface from order service. So all the public methods on order service class are in an interface. Change the type of my order service class to be order service, which I pass in through the constructor. And then I can inject that. I can create a fake object and pass that in instead of the real order service class. The two types of fake objects. So a fake object is the easiest type is it just does nothing. So it returns null. It's a stub. Does nothing. So my order service class, when when it calls order service from order controller, nothing will happen. That's the easiest, and that works in quite a lot of cases. I mean, say if it's just logging, for example. So order service, and because order service.log this, that'll return null. So it won't do anything, and the rest of the logic will work. But sometimes you require a bit more than that. You want it to return true or return a list of something, and that's called a stub. You can make these very easily yourself. So if I have an I order service class, then I can just create a new test class, test order service, implement all those methods on the interface, but most of them can just be return null or nothing, return true, return false. And then maybe if I need one or two methods to actually return something, I can do return new list of something. That's pretty easy, and that means that you've isolated the code in your controller class. That's what I want to test. I want to test a unit. I don't want to test the whole chain from order controller down to the database. If you're going to have lots of these tests, the feedback is too coarse-grained. It'll take ages. In a big system, there might be like 10 layers, from top to bottom. It'll take a couple of hours to run all the tests if they all look like that. You want to focus on that little bit of code you're working on. You want fast tests. You want to just to focus on a unit. And there's another type of fake object then called a mock. I think I won't go into that too much, but it's very similar to the stub, just that you want it to verify that I've called a method. So an order controller, if I want to say, I just want to verify that you actually did try to send an email. Don't send it, for real. Just check that you did. There are three very good fake frameworks in .NET: MockU, and Substitute, and Fake It Easy. I'd say they're all pretty much equally as good. I'd say start with making your own fakes. Then once you get bored with that, you can start using MockU and then Substitute and Fake It Easy. But I would say that it's always good to mix both. Don't go too much in the framework. Don't go too much on your own fakes. So here we have a testable code. So this is our order controller. There we pass in an I order service, which means that I can now write a test for it. So here I have can send order confirmation email. So here I do a mock. So I do order controller, send confirmation, pass in an order ID, and now my order service, it isn't a real order service anymore. It's just a mock. So I just say, can you verify that you've actually sent the email? If you're wondering how it would actually create an order service, then there's a couple of different ways. They're a bit outside the scope of this. The easiest way to do it is just create a default constructor, so public order controller with no parameters, and in that then you would just do base and pass in a new order service. So all code would just work the same way as it did before. And then once you start getting a bit more advanced, then maybe you can start looking at IOC containers. The next case then is the case of the irritating parameter, because this is all well and good if you own the class. So I order service is my class. I can extract an interface from it. So my order service class now implements I order service. But that doesn't work if it's a .NET class which is sealed. I can't go in and start extract the interface from it and change it. So have to, which is really common. I mean, SMTP client. I can't change that in any way at all. So how am I going to get at that? Because as it looks now, if I want to test the order service class, because now we've moved down a level, so we're not testing order controller anymore. I want to test order service, but without sending emails and without sending anything to the database. So under that, you see I have a send order confirmation to customer. There's the method. Gets an order from the order repository, and then creates an email and sends it off. Yeah, there's two ways to approach this. There's actually lots of ways to approach this, but we'll focus on two. When you do wrapping or skinning, so we want to take our SMTP SMTP client and in some way do a little wrapper around it so that we can test it. And the hard way to do this is called skinning and wrapping, and that's you take the whole SMTP client and do a wrap around it that calls every single method on SMTP clients, like a replacement for it. And it doesn't do anything. It's pretty dumb. It just delegates. It just calls the different methods on SMTP client. And if that's a big third-party API, then that could take a long time and a lot of testing. So an easier approach, and which I would use in this case, is responsibility-based extraction. And that's the only thing I'm going to use SMTP client for is to send an email. So I just do a wrapper just for that. Show you what that looks like. So I create a little interface. It's only got one method on it. Send order confirmation. It's the only thing I'm going to use SMTP client. I don't care what the other methods are. And then I can call it from my class. So now we've seen that I've reduced the class down to a much smaller one. We've taken out the SMTP client code and moved it into a new class. So I just go email composer.send order confirmation, and that looks like this. So this, if I'm going to test this is an integration test. This isn't the unit test. So this actually sends emails for real, and that can be useful to test as well. But now I've moved that bit, that hard to test bit, into its own class. If I can test my order controller, my order service without sending emails, and then I can have like a third test for testing, my email server, is it set up, and things like that. And this is what my test now looks for order service. So you see in setup, I have two fake classes. So one for my order repository, that's my database class, and one for my email composer, and that's where I send emails. And I pass them in as objects into my order service through the Constructor Injection. And then in my test, so the setup is done before. When I actually start test, then here you can see I'm doing a stub. So saying my order repository setup. So I'm saying that if it gets the call for get order by ID, then it should return an order, and that order is just an empty order, a new order. That's all I need. You should try and keep your tests small. Don't write too much setup code. It should be easy to understand. So this is 3 simple steps. You set it up, you call it, and then you search. So my last one there, email composer.verify, and just check that that it actually got called and that an email got sent. Okay, some general refactoring tips. Extract method, really useful. These are sharper refactorings. You can use them all the time. You can be nearly 100% certain that you don't break anything. Break things up. Rename things. If it's called, I think I've seen a method with I can't remember what the method name was called, but all the parameters are called oppa 1, oppa 2, oppa 3, oppa 4, oppa 5. It's just like, what are those? I have no idea. So you have to, once you go through the code, you understand it, you change and give them meaningful names. Next time you go in, it'll be much easier. You just, at a glance, you can see, well, this is what this method does. And then break up your methods. If you've got your 500 line method, then extract out, 3 lines that you want to test into its own separate method, and test that. And you don't have to, take the whole thing in one go. And then, don't mix different abstraction levels. This is really common. You see it all the time. So you have maybe some sort of high level, like send invoice, and then or save invoice, and then under you have like loads of SMTP code for sending an email. So totally different abstractions. It makes it really hard to know what's going on. So extract low level stuff out into its own methods, so that your calling method is mostly high level, and then when you go down and look at that method, and that does the low level stuff. The next one is command query, and that's sort of along the same lines. That most code is either a command, it does something, or a query. It's a question. It's asking for something, wants something from the database, and try not to mix them up in the same method. I mean, see this all the time in web forms projects. So you have a button click. It does everything. It saves the database. It gets stuff from audio.net. Sends email all in one method. mixed up with events and stuff from web forms. It's like what's going on here? How can I change this? How can I test this? And the only way to do it is just sort of massage it, start taking out the bits that make sense and try and test those. And in the end, you're only left with like a sort of thin skeleton, which is very easy to understand. And the last one then is refactor similar methods to be more similar. It's the whole don't duplicate your code, DRY. So if you have two methods that are very similar, then you sort of refactor them, massage them. They're nearly the same, but they're not quite the same, and try and get them to be as similar as possible. And after a while, you can just remove one of them. There might be like one little bit that's unique, but 90% is exactly the same. And you can extract methods out there the same, then you can reuse your code, which is a huge problem in legacy code databases or code bases. I think we've all seen this where somebody has taken a huge chunk of code, said, "Oh, I need to do something like this, but it's not quite the same. I want to change a few bits, and I don't really want to go in and change the old code because I might break something. So I'll just Control C, Control V here, and then just change it a little bit. And then you come and look at that and you go, oh, I have to make a change. I have to make it in 2 places or 3 places maybe, exactly the same change. And then maybe I don't make the change in exactly the same way in all 3, and just make it more and more complicated. Try and simplify it instead. I would say that this is actually a really, really great way to learn TDD. That you learn, it's actually way better way to learn TDD than greenfield projects. The problem with greenfield projects is that most of the time you don't actually have to suffer through your own mistakes. If you don't really get this, with the code design right, because people can believe something, TDD, that'll lead me the right way. I don't actually need to know anything about design. Just have to sort of do TDD, and it'll get be perfect code, and that's really not the case. I think it's actually the opposite. That if you're doing TDD, it actually is a bit more challenging. You have to learn more about how refactoring. How do I write good code? And you get a real feel for that in legacy code, because we have something called code smells, and that's things in the code that are they're wrong, they're difficult, and they are really, really obvious when you do TDD with legacy code. I mean, for example, if we're doing Constructor Injection, so I've lots of different dependencies. My example had 1 or 2. But in real life, it'd be 25 maybe. So then you have a constructor where you're passing in 25 different classes, and you're trying to write tests for that. That's really painful. You're trying to set up 25 different dependencies, and you just go, God, this is really hard. And that's an obvious code smell. It's a class that does too much. Why does it need 25 classes? It's not doing one thing. It's doing like 20 different things. You have this huge, like say, order service class. And it does everything to do with orders, and it's huge. It's like 3,000 lines long. It's a code smell. It's screaming. It's saying, "Break me up." I'd say if you're doing TD, you get a lot of practice with refactoring, which you don't get otherwise. Because most times you're just being really, really careful. You're making very, very small changes. You can't just go in, I'm going to change the structure of this, going to totally do it a different way. This is all wrong. I just thought of a much more elegant way to do it. You can't do that in legacy code. It's just too risky. But if you've got your unit tests, then you can, you've got it covered. In the worst case, you can just say, don't check it in, just throw it all away and go back. You have that safety net, which means you get much, much better refactoring. Notice myself just the last 2 years since I started with TDD that I've taken a huge jump skills wise, and you get to practice all these design skills which maybe you've read about before, different patterns and things which were just entirely theoretical before, because you never went around using the strategy pattern. So you have a switch statement and say, I could refactor this to be a strategy pattern. You just don't do it because just too much time, too hard. Thank you. Okay, so success in legacy code. Even if you do all these tips, you're refactoring, you read Michael Fella's book, and you know how to fix legacy code, and your whole team is working on it for a year. It's just never, ever, I'm sorry to say it, it's never going to be a beautiful elegant database or code base, it's always going to be a bit ugly. It's always going to have huge chunks that just never get changed. You know, the unimportant bits, the admin section that no one cares about. It's going to look horrible. And you know, if you're starting with a lot of code, and to get that covered by tests, that takes a long time. So to be honest, if you get up over 20 to 50% of your code covering tests, that's wow, that's amazing. Then you've been working really, really hard. But I would say it actually doesn't really matter. The other 50% doesn't usually matter that much. As I was saying before, that when you make changes, you tend to make them in clusters. So you're implementing a new feature. So you fix the classes around the classes that are related to it, and then pretty soon, when you're fixing bugs or adding new features, you're changing the important parts of the system, the core of the system, and they'll get covered by tests pretty quickly. And the other bits that are less important, they'll still be a bit buggy. So there might be a button in the admin section which, if you press sort of on the wrong day of the week, it'll crash. But I mean, it's only 3 people that use that button. It's not the main part of the system. And the important thing is that you stop having critical bugs, because that is so demoralizing working with legacy code when you introduce critical bugs. So you're making a change, you're trying to make it better, and oh no, it just messed up the invoicing logic, and that cost our customer 300,000 euro. Yeah. And I'd say as well for you, it's not just for the system and for your customer. That I mean, for you, the developer, taking this path, doing TDD with legacy code, it actually makes it possible to succeed. I would say, otherwise, it's an impossible situation. You come in with a buggy system with loads of legacy code. It could be your first day on the job if you're unlucky. You're just never going to have happy customers. You're never going to know what it's like to actually have a successful delivery. And this actually sort of changes the odds, that you can slowly, make it better. You can cut out the bugs. You'll notice a change in your customer's attitude very quickly when you can do a demo without crashing, when they can use the system for a week, without any major bugs, or if you add a new feature and it actually just works, as they intended. It makes life so much easier. And so the TD as well. You feel actually that you're getting better every day, because if you're stuck in legacy code, you often feel like I'm not learning anything new. I'm just hacking away. I'm just doing the absolute minimum, just working 9 to 5 and then going home. I say you can learn new design skills, all this with patterns and refactoring and everything. You can actually use them now. And even better, it's actually possible to set goals. You can actually, after a while, start saying, this will take 2 weeks to implement, and it'll take around 2 weeks, and not like 3 months. And it makes life so much more enjoyable. Okay, my next experience. Every speaker has to write an experience, and I see a lot of legacy code. So what I would really love to see is more developers doing more than reversing the rot. I want to see happier devs, more satisfied customers. I want to see people take it to the next level. So not just fixing up the systems, but actually getting into continuous development if it fits your business. That you can do so much more with your code. You can do a much better job, be happier, and have much happier customers. Okay, and that's it for me. I hope you learned something, and maybe a bit more inspired to clean up your legacy code. Thank you.